Alright, and welcome back to this class. In this tutorial, we are going to learn about object-oriented programming, OOP, laying our focus on classes and objects. You are going to learn how to create your own class and how to define some variables and define functions in classes. And so we are meant to understand that classes are one of the important concepts in programming at large. So in this tutorial we're going to learn about classes. We're going to learn about classes in Python and how to create classes, how to create how to create a class as well as its objects, because every classes must have an object. Every class must have an object. So a class can simply be said to be a kind of sketch plan or blueprint for creating an object. So a class can contain functions or methods and data of different types, and as well as variables. So to create a class, we use the keyword class. This is the keyword we use. We use this keyword class to create a class. We use the keyword class and then followed by the name of the class name. I say name of the class. Alright, name of the class. So this is the syntax. Then followed by column. We use the class keyword, then followed by the name of the class, any name you want to give to your class or whatever you want to name your class. Then after the name of the class, we then followed by a column. Very important. This is the syntax for creating a class. For example, if I want to create a class named car, this is the name of the class I have created. You can see, followed by column. Then Python automatically gives us an indentation. Then I'll say name equals car. Let's say we use the name Camry. Say the name of the car is Camry, and then I'll define the number of wheel of the class, and then followed by the number of gears. Here you can see that car is the name of our class. That's the name I decided to give to my class. Then the class description, that is the class description here includes the wheel and then the gear. These are the class description, or you call them the attributes of the class. They are class attributes or class variables. The car is the name of the class. So we use the class keyword to define our class and to create our class, then followed by the name of the class, which is car, and then followed by column. And so after which you now define the attributes of the class. The attributes of this class includes the name, the wheel, and the gear. These are what we call attributes of a class. Now we talk about class objects. As we know that Python is an object-oriented programming language. That is to say that everything in Python is referred to as an object, because it's an object-oriented programming language, and so it refers everything to be an object. And an object is referred to as the instance of the class. When you hear about the instance of a particular class in programming, an object is referred to as the instance of that class. So a particular class can contain as many objects as possible. So to create an object, just note that you must exit this indentation and then define the name of your object. You can use any name as your object name. We use this object to call the attribute and everything that belongs to our class. That's the purpose of creating an object in a class. So I can use any name as my object name. Let me say object1, then equals, or you assign it using the assignment operator, then the class name. Look at it, class name, then followed by parentheses. This is the syntax for creating an object in Python programming. The name of my object here is object obj_1, then equals to the class name. My class name here is car. So here I'll put what? Car, then followed by parentheses, because I'm calling the attributes or the functional attribute that belongs to my class. So this is basically how to do that. So if I want to upgrade, if I want to create that particular thing, let me upgrade on this. I'll remove this and make it 0, and remove it and also make it 0. We use the class objects to access all the attributes of a class. Without the class object, we cannot really access the attributes of any class. And so attributes, which I said includes the name, we, and gear. These are what we call attributes, or you can call them the variables created in the class. So the attributes are all variables which are created in a particular class, and we use the dot operator to access all these variables or attributes. That is the object name dot attribute name. This is what I mean. After creating your object, then you assign it to the name of the class, followed by parentheses. We now use the object name, and followed by, my object name is obj_1, then followed by dot, so that we can use it to access the attribute of this class. So I'll now use, my first attribute is name, so obj_1 dot name, then equals Camry, all right, then obj_1 dot wheel. Here I'll now specify the number of wheels which my vehicle or the car class contain. So I'll now come again and use obj according to the number of attributes you have in that class. Object_1 dot gear equals 10. So this is just a narration. I'm using this to describe and to narrate what an object is. So you can see we have used our object name to access all the attributes of this class. So I'm going to print it. If I print this program, then I will have f, using the f-string method. I'm going to have car name, and just say car name, then I'm going to have obj_1 dot name. This is car name. Then I'm going to use this /n, then I come again, and then car wheel. I use number of wheel or number of wheels, then into this obj_1 dot wheel, then close parentheses, and as well this, all right, and then number of gears, okay, number of gears, and into I have obj_1 dot gear. So if I now run the program, my program, you can see the result. So we have our car name to be Camry, then we have number of wheels, which is 4, and our number of gears, which is what, 10. So this is basically how to create a class and how to create the object of that class, and then use the object of the class to access all the attributes, that is the variables of the class. Is it understood? For example, let me create another class. This is another way to access the variable of a class. Let me create another class here. I'm a code, and then I'll call this class num. Right, then I'll come down and define the class attribute, create a class attribute or a class variable. After creating this variable, I'll now create my object. I can use D as the name of my object. Remember I told you can use anything as the name of your object. Then you now call your class name followed by parentheses. You have called the class methods or function. Method is also known as function. And so if I print this, you can see I'll print my method name dot x, because x is the name of my attribute. So my method name, my object name dot my attribute name, which I told us. So we use our object name, then dot the attribute name to access all the data that are stored in our attribute. Is it understood? If I run this program, you see the result here. We have 8 at the terminal. That's the result of our program. Is it understood? So a class can also contain functions or methods. Like I told us earlier, that function is also known as method in programming, in Python programming. A class can contain function or method, as many as possible. You can have many functions or many methods in a class. So let me create another class to add 2 numbers, a kind of a class that will be able to add 2 numbers, and then I'll define a function in my class. So class add followed by colon. I've defined my class. Then I have created my class rather. Then I'll now define using the def keyword. We have known how to define function. Calc self. This self is an initial parameter that must be in the function of a class. So do not mind it. You have to take note of it. This self can be any name. You can name it anything, but I decided to use self. It is the initial parameter of any function in a class. Any function created in a class must have this self parameter before any other parameter. You can see in my function name calc, inside my function name parenthesis, I have self and x. X is my second parameter, which is an optional parameter, but self is a must parameter. We use the return keyword. As you can see, the color changes because it's a keyword. We use the return keyword to return the value of any operation done in that function. So we are going to return x plus 1. So we now come down after this, come down and then define your object, then assign it to the name of your class, that is calling the class attribute and the method and every functionality that belongs to the class. Now then inside this print function, we now call the name of our object dot. Is it understood now? So I'm using this to access the variable or access all the functionality of our class attribute. So we use our object name dot our attribute name to access all the functionalities of that class. Then I'll now pass 8 as a value to be added to this one. So when 8 is added to 1 or 1 is added to 8, it gives us 9. It returns what? 9. You can see here, if I change this to 10, you will see it will return 11. If I change this to 10, it will return, and run the program, it will return what? 11. You can see this is how it works. So all that we've been doing all this while are classes in its simplest form. All we've been created from the beginning to this point are all classes in its simplest form. So to understand the real life application of classes, we need to understand the built-in init function. That's what we call the init function of a class. The init function is the init function I'm talking about. You use double underscore, then init, double underscore, then followed by what? Parenthesis. This is the init function. To understand the real life application of a particular class or any class in Python, we need to understand this init function and how to use it. So all classes have a built-in function called the init function. The init function is always executed whenever a class is being initiated. This is how the init function works. So this init function is a built-in Python function that comes with any class being created, and its attributes are always activated whenever a class is initiated or created. It is used as well to assign values for class attributes, and it is called automatically whenever a new object is created. And so it's also called class constructor. In many programming textbooks you will see it, they call it class constructor. When you meet any programming textbook that you see class constructor, what they mean is this init function. So the init function is also referred to as the class constructor. So now we are going to write a simple program that will calculate the area of a rectangle using classes. How do we do that? I'll create the class and name it rectangle. I'll name it rectangle. Alright. So inside this class, I'll now define def, then define the init function now, init double underscore. Then inside the init parentheses, you use your self parameter. This is an initial parameter that must come with any function created in a class. This self, you can name it anything, whatever you like, but I prefer using this self. And then after the self, I'll define the breadth of the rectangle, and then followed by the length of the rectangle as well. So these are the two optional parameters I created in this class. And so we use the self keyword to assign or to create, to get the attributes of each classes of any function in a class. So we use self.breadth. Self.breadth equals breadth. Self.breadth equals the breadth we have in our init function. So we have self.length. Self.length equals length. Is it understood? So this is how to use the self keyword. Remember, we are creating a class that will be able to calculate the area of a rectangle. So we come down and define another function, call it area of a rectangle. Then inside the area, self. One thing with this self is that every other function created in this class must have this self parameter. And so we'll now return the area of this rectangle. You know, the area of a rectangle is breadth times length, and so we return self.breadth time self.length, because self.breadth has been assigned to breadth and self.length has been assigned to length. So we have them stored in each of those variables now. So we'll now come down and say length. We'll now create a function that the user can enter. So now enter breadth. Now say enter breadth. Then now come down again and say breadth. Just use breadth equals int, and then input enter length. All right, so this is an input where we accept data from the user. So after this, we'll now come down and create our object. Is a must. Every classes must have an object. So we'll now create an object which is d. D is the name of my object, and then I'll assign it to the name of my class, which is what? Rectangle. You can see here, rectangle. Then inside my class parentheses here, since I have called the function and all the attributes, I'll now pass the parameter that the user enters, the length and the breadth. Is it understood? And then I'll come down and print the area of triangle is, or let me just say print. I'll use the f-string method. All right, print area of triangle, then d.area. I'll now call the name of the second function created, not the init function. I'll now call the name of the second function created, the area function. Close my parentheses. Just go through the program. This is how it looks like. So you can see, if I run this program now, you can see the area of triangle is what? 120. So this class calculates the area of triangle using the breadth of the triangle and the length of the triangle. Is it understood? This is basically how it works. So if I run the program again and enter the breadth as 5 and then the length as, let's say, 6 times 5, 30. You can see the area of triangle is what? 30. This is basically how to do that. And you should note that the init function can contain many parameters as possible. The init function is not limited to a number of parameters. It can contain as many parameters as possible, but must have an initial parameter called the self parameter. Is it understood? The init function can contain many parameters, but it must have an initial parameter, which is the self parameter. You can name that self parameter anything. So it must contain that parameter, which is referred to as the current instance of the class. The self parameter is referred to as the current instance of the class and is used to access the variables or the attributes that belongs to that class. That's what you can see now. This self.breadth, we use it to access the breadth attribute. Then self.length, we use it to access the length attribute. This is how the self parameter works. And every class, every init function created in a class must contain this initial self parameter before any other parameters. So the self parameter can be named whatever you like, but it must be the first parameter of any functions in that class. As we created this function area, the area function, you can see self is there because it must be the first parameter or the initial parameter of any function in a class. As we created the init function, self came first. Is it understood? So this is basically how it works. And so the class attributes are categorized into two. We have the class variables and the instance variable. The class variables are the ones created normally inside the class, while the instance variables are the ones created in the init constructor. Is it understood? The class variables are the variable created inside the class, like the initial classes we created without the init function. Those are called the class variable. We also have the class inheritance. In Python program, we have class inheritance. How to inherit classes in Python. Let me remove this to explain better what class inheritance is all about. So in Python, a child or derived class can inherit all the properties and methods from the parent's class. We can create a class and then create another class inside that class. That's what we call class inheritance. Then the second class will inherit all the properties and method or functions that is created in the first class. That's what we call class inheritance in Python. And so the parent class is the base class. You can call it the base class or the parent class. While the child class, either you call it the child class or a derived class. That is the class that inherits from the parent class is called the derived or child class, while the class that is being inherited from is called the parent or based class. So let's create a somewhat class called detail class. This is you use the class keyword and then detail. That's the name of my class, detail. And then I'll use the init function now, double underscore init, then double underscore, then it must contain f. Inside the init parenthesis self, you call the self parameter, then name, and then address. Alright, so these are the parameters, or we call them attributes, of the init function. Then I'll now use the self keyword to call these attributes in my init constructor. That is the name and the address attributes. So I'll use self.name equals name, self.name. That's settled. Then self.address equals address. Alright, let's change this address. Okay, and so we'll now come down and then define another variable, another function rather. I'll define another function which is, I'll name it my detail. You can name your function anything. my detail. Okay, then we now call the self parameter. It must be the first parameter in any function of a class, the self parameter, and then I'll now print using the f-string concatenation method, print name. Then we'll now call the function, the attribute, that is self.name here. Alright, then I'll use the /n. I also have address, that is self.address. Okay, then let's come down and create our object. Remember, we use the object to access all the variable, or to access the attributes and all the functionalities of a class, and as well as to call the class into function. So I'll create my object. I'll use D as the name of my object. Then I'll now assign it to the name of my class. My class name is detail. Then inside this detail, I'll now pass the parameters that belongs to those class attributes or variables created, name, Paul, and then followed by the address. Let's use 58. Alright, then the address, let's just use 58 Bory Street as the address, and then D dot the name of that function, my detail, the name of our function. We are calling that function here because, you know, if you create a function, you don't call the function, it will not be initiated, it will not be activated. Just go through the program a bit. You can see if I run this program, you can see, okay, opening parentheses, where is that? All right, so this is a mistake. This is a normal parenthesis and not square bracket. So you can see name Paul, you see address 58 Bory Street. Then how do we inherit from this class now? You can see this class, we have name as an attribute which contain Paul as a data stored in that name attribute or variable. Then we have the address attribute as well. But let's create another class that will be able to inherit all the attributes or the characteristics and functionalities of this base class. This class now, the detail class, is called base class. We are going to create another class which is the child or derived class now, so that it can inherit the properties and methods of the parent class. We can do that by creating another class and pass the parent class as a parameter inside the child class parentheses. What do I mean? Now let's create another class, then I'll now use age. Let's use anything. I'll use anything as the name of the class. Let me use anything as the name of the class. Then I'll now pass the first class, that's the parent class or the base class, as a parameter inside the first class, inside the child class parentheses. So the name of that first class or the parent class is detail. You now pass it as a parameter inside the child class parentheses. Is it understood? This is how to create an inheritance class. Then we now pass. With this pass keyword, we use the pass keyword to call or to access all the attributes and functionality of the parent class inside the child class. So this is the syntax. So with this, all the properties and functions and functionalities of the parent class has been accessed and inherited by the child class with this program using the pass keyword. And we use the pass keyword when we don't want to add any more detail to the child class. If you don't want to add any more details to your class, then you now use the pass keyword. This pass keyword enables you to automatically achieve or inherit all the functionalities and attributes of the parent class without an external or additional methods or variables. That's why we use the pass keyword. But in case you don't want to use the pass keyword, you want to add more details to your class, we can create more methods in the child class. Instead of using the pass keyword, we use the super function. There's what we call the super function or the self attribute. So if I run this program, you can see we have name as well. You see what happened? We have name, Paul, an address, and so on. So this is how to inherit. What we printed out here at the output, what we printed out here at the terminal is what we have in our child class, because our child class automatically access or inherit everything, all the attributes and functions of the parent class, of the detail class. This age class has inherited everything in the detail class. What if you want to inherit all the attributes of the parent class and as well as get a new method or a new object in the child class? How do you do that? Create another method. Here we will not use the pass keyword because we don't just want to access or inherit the variables of the parent class, but we want to have additional methods in the child class, which will be printed at the terminal alongside with the ones we have in the parent class, the ones being inherited from the parent class. So we'll now have age to be 23. We'll define my age, def underscore my age. Alright, then we'll now have self. So we'll now define the age to be 23. Okay, and then we'll print using the f-string method, print age, then self dot, or let's just call age, just call it age. Okay, that's that. Then we'll now close the parentheses. Alright, if this is settled, then we'll now come down and then create an object for this class. Let's say object obj equals age. This is the name of our child class. We'll call the name of our child class because automatically everything in the parent class, the detail class, has been inherited by the child class. So all we need to do now is to create the object that belongs to the child class. So we now have obj dot my age. That is the name of the function we have in the child class. Now obj as well dot my age. Alright, we call the function or the method of the parent class and then the function or method of the child class. If I run the program now, you see we have name Paul, address, and then we have age 23. Is understood? This is how it works basically. So just go through this and understand it better. You can have as many classes as possible, and so we can as well use the super function to inherit all the properties and method from the parent class. We can as well use the super function. This is how the super function is. Super, it's a built-in Python function that is used when creating a class. So we can use this super function to access all the method and attributes and properties from the parent class. Let me remove this and then get you to understand better by using the super function. Let's create a class. You can use the super function to access all the attributes of the parent class. Name is the name of my function, then def, I'll define a function, my name, and then self. Alright, then I'll now return Paul as the name. That's the data stored in my name. Then I will now create the child class. I'll now create the child class. I'll now name it print name. That's the name of the child class. And then I'll now pass the name of the parent class as a parameter. inside the child class parentheses. So the name of the parent class passed as a parameter in the child class parentheses, and then I'll now define another function in the child class, get info, or let's say get name, then self. Remember, the self parameter must be the first parameter in every function in a class, every function created in a class. Then this is how to use the super function. Name equals super, then followed by parentheses dot. We use the dot character to access the attributes of the parent class. We use super function, then followed by dot character to access the attribute. Now we have my name as a function is being called here, and so we now print using the fstring method, print my name is name. Is understood? Then we'll now come down and create an object for this class. Let me just name it D, and print name. We'll assign it to print name. Since it's a function is being called, then now use the object we have created, the object of this class, which is D, to access the attributes of that class, the attributes of the class, which is get name. D dot get name. The parent class called name, and then the child class called print name. They will now use the super function to access the attributes of the parent class. So if I run the program now, you will see my name is Paul. You can see it's printed at the output now here at the terminal. So this is basically how to inherit, use the child class to inherit properties of the parent class. This is what we call inheritance in programming. So in Python programming, we have up to about 5 types of inheritance. We have the single inheritance, that is the one we created. The one with just a parent class and a child class is called a single inheritance. Then we have the multiple inheritance. The multiple inheritance is the inheritance with more than 2 classes. That's what we call multiple inheritance. The single inheritance is the child inheritance and the parent inheritance. It contains just these 2, while the multiple inheritance contains from 3 up. We may have the child class, the parent class, then another class follows. Then we also have the multi-level inheritance. The multi-level inheritance contains many classes. Multi-level inheritance contains many classes, and then it has to do with the relationship between the child class and maybe the grandchild class. That's the multi-level inheritance. The relationship between the child class and the grandchild class. We also have the hierarchical class, and then we have the hybrid class. These are the 5 types of classes in Python at large. And so just practice all this and get used to them. Thank you, and see you in the next class.